The software quality assurance component has been designed to address the activities that are required to ensure that software developers do it right the first time. SQA encompasses basic quality philosophy, technical tasks, and organizational approaches. This component is presented in 3 modules: software quality, SQA activities, and software reviews. This module, SQA activities, will help you to understand the role of software quality assurance in support of a software project. SQA tasks are identified. The role of the SQA team is defined. Statistical SQA is discussed, and other SQA concepts are introduced. And now Dr. Pressman on software quality assurance.
Hello. Software people think that software quality assurance is something new, that it's been with us for only a short period of time, and that now we can take significant advantage of the control mechanisms associated with SQA. The reality is far different. Software quality assurance is an idea that was introduced to American industry in the 1920s, and subsequently it's been used across a broad spectrum of products and systems. It is, however, a concept that's relatively new to software people. And for that reason, it's very important that we cover it in depth. With the increasing emphasis of the Software Engineering Institute Capability Maturity Model and ISO 9000, software developers worldwide have a significant interest in software quality assurance. And that's what we're going to be looking at in this ESE component. Let's begin.
SQA is relatively new to our business. No more than 20 years ago, when people were still programming in the classic sense, no one really had a concept of detailed quality assurance for computer software. It was sort of, you wrote the program and you tested it out, and hopefully it worked, and if you had embedded into some kind of a system, you tried to do that as best you could, and if there was quality assurance, it was applied strictly at the system level. But as time passed and software became a more significant part of embedded systems and general computer-based systems, there began a trend towards specific software quality assurance that is applied throughout the process of creating computer programs, okay? Creating the documents that define them and the data that drive them. So when we talk about SQA, we're talking about something that actually is relatively new. Now, what is software quality assurance? SQA is always based on an examination of requirements. Why? Think about our definition of quality. Conformance to implicit and explicit requirements. So requirements are going to be the basis, as it were. Beyond that, we have to think about QA in terms of a number of distinct activities, okay, major activities that are visible from the software engineering process.
The activities that we associate with software quality assurance span a rather broad spectrum of both management activities and technical activities. From the management point of view, we focus on total quality management as a first step, and then move on into a variety of project control tasks and steps. We'll talk about those a bit later. From the technical point of view, our dominant focus is in 2 places: the area of formal technical reviews and testing. We'll cover all of these things along with measurement and many other software quality assurance activities as we work our way through this ESE component.
We have to think about QA in terms of a number of distinct activities, okay, major activities that are visible from the software engineering process. I would say that set of activities that you see on the slide is probably the most important set. It's not comprehensive, but it's the most important set. And if I had to pick one of those activities that is absolutely most important, I could do that.
Before we answer this question, let's survey some of the key software quality assurance activities. When we think about SQA, we have to begin with an emphasis on total quality management. TQM has been with us for some time. When an organization adopts a total quality management point of view, it emphasizes quality in both products and services. Beyond this, we move into the world of SQA. SQA begins with measurement. We have to measure both the product and the process in a way that will give us some indication of quality as we proceed. We have to establish a set of standards and procedures that will be workable for the software that we build. We must apply a set of methods and tools that will enable us to design and then create a high-quality product. We apply formal technical reviews to assess the quality of our work prior to the construction of an actual computer program. And finally, we have to control change through configuration management in a way that will enable us to achieve quality both during the development process and as the product is in the field and being supported. All of these activities are part of what we call software quality assurance, and all of them must be emphasized when we take a total quality viewpoint to software development. Returning to our question, which is the most important of all software quality assurance mechanisms and why? If someone were to put me up against a wall and require that I suggest just one thing that could improve software quality, the thing that I would recommend is for your organization to conduct effective, formal technical reviews. We're going to talk about reviews in some length in a separate ESE component, so I won't stress the issue now, except to say that if you do reviews and do them well, you will produce high-quality software.
Deming, who is the godfather of total quality management and process improvement throughout the world, argues, as you note on this chart, that any process that doesn't have distinct quality management focus wastes anywhere from 25 to 40% of the effort applied to it. That's a pretty strong statement. I'm not sure that that can always be proven, but Deming is very well respected. Okay, so you got to kind of sit back and say, wow. Now, what does that mean? Well, that swings us back to the quality is free issue that Crosby talks about. If you apply quality management technique and, in fact, you spend, let's say, 20% of effort doing that, but you have the potential for saving 25 to 40% in waste, you get good return on investment.
Dr. Pressman, why do we continue to struggle to make TQM a reality in the software development business?
There is still the feeling among too many folks in the software community that this is really a technology problem. And if we just get the right methods and tools into place, quality will improve de facto. The reality is that it is a process problem. That is true. And that until we get our process act together, there is no hope of doing the kinds of things we need to do simply with technology. It is also a cultural issue. Part of getting a good process into place is also getting a good culture into place. At the top of our SQA pyramid, we find configuration management. Change occurs throughout the process, and it's necessary to control it if we're willing to achieve high quality. Let's take a look at SCM, Software Configuration Management, in just a little bit more detail.
Software quality assurance has a configuration management component. Configuration management is, boiling it all down, the control of change. It's actually more than that, as we will see. But it's basically the control of change. I view CM as part of QA. Other people don't. They feel that CM and QA are separate and equally important activities. to be frank, I can live with either view. There's no fundamental problem.
Software quality assurance activities take time and cost money. But many people believe that the time and money we spend is actually an investment. Why? Well, simply because the time and money that we spend on software quality assurance saves us significantly more time and money later in the process. The reason: we find errors early in the process when they're less expensive to both find and correct. But more on that later. For now, we're going to talk a bit about payoff of software quality assurance, and trade-offs. What are some of the issues involved as we implement a software quality assurance program? We'll explore these issues in the next few classroom segments and in some newsroom discussion.
Why don't we simply let testing be our primary quality filter? Why do we need all these people, all these activities, and frankly, all the overhead that are introduced as a result of these people and activities? Why don't we simply let testing be our primary filter? The problem has to do with the cost to find and fix a defect, an error. Okay? If you look at the histogram, what do you see? The vertical axis, cost to find and fix an error, a defect. Okay? Log scale. Horizontal axis, each of the major software engineering process activities. We'll normalize cost at 1 unit during design. If we find and correct an error during design, it will cost us 1 unit of money. If that error had been fixed during requirements, during a review or discussions at requirements, it would cost us about 25% less, 75% of the 1 unit. If, however, we miss it and it creeps into code, it will cost us, on average, 50% more. If we don't catch it during code and it enters into low-level testing, this is pre-integration testing, it will cost us at least 3 times, and in some cases up to 6 times as much to correct the same error. If we don't uncover it until we get into system integration, but pre-delivery, we're now up to 10 times as much money. And finally, if we don't catch the error until it sneaks through, becomes a defect, and goes out into the field, then, in fact, there's almost no limit. We're up to 60 to 100 times more expensive to find and fix the problem.
Are there any other factors that have a bearing on cost and therefore justify early SQA activities?
There is a tendency when an error is introduced at any stage in the software process, not only for that error to proceed from stage to stage, okay, from analysis to design and from design to code, assuming it's not found, of course, but there's something else, and it's worse. In fact, it's scary. Very often, an error introduced in analysis amplifies when it reaches design. One error turns into a number of different errors as a result of it. And then when it gets to coding, it's manifested at many places during the program. It's amplified again. The implication being that as we move into the system, a single error becomes multiple errors. Each of those errors is expensive to find and correct, and we have a real problem on our hands.
So we find that the payoff comes from 2 different directions. First, we save money because we reduce the number of errors that need to be found later in the process, when they're expensive to find and correct. Secondly, we save money by reducing defect amplification. Errors that might amplify into more serious errors are eliminated early in the process. For these reasons, software quality assurance pays off. But it's also important to consider the trade-offs associated with software quality assurance. And that's what we'll do at this point.
There's the argument that if we don't spend enough effort on quality, project and life cycle costs are going to be very high. As we ramp up our emphasis on quality, overall costs, life cycle costs, should drop and drop down to some minimum. But we can go too far. We can put too many filters in the flow, as it were. And if, in fact, that happens, costs begin to rise again. I think we're not quite sure exactly where this minimum is. The implication of this chart is somewhere around 20% of effort, more or less. Okay, and I can live with that number. Now that's a big number for some of you. Think about that for a second. What we're saying is 1/5 of all human effort being applied to a software project goes into one or more quality assurance activities.
Dr. Pressman, is it possible to go overboard in emphasizing SQA?
There is a point of diminishing returns. Okay, and that's really what this represents. If you're spending very, very little time on quality, the number of defects detected, the number of errors detected, and ultimately defects that go out into the world is not really going to be very good. But as you begin to hit the 20% threshold, you really begin to arrive at a point of diminishing returns. You're just spending a lot of effort, and you're not getting a tremendous return on that effort.
Does the 20% number include technical activities such as design?
When I say quality assurance efforts, what I mean is efforts that have been created to ensure that either analysis, design, or testing has been properly characterized. Okay? So no, this number does not include design, if that's the thrust of your question.
Dr. Pressman, how much time as a percentage of project effort would we be spending on reviews?
The general rule of thumb today, most people believe that you ought to be spending for reviews about 10 or 12% of project effort. That's a lot, okay, particularly if you're not used to it. But reviews are such a powerful quality filter that if performed correctly, they will pay themselves back. Again, it's this issue of quality management and waste. They will cull out errors early when they're cheap to find and cheap to fix.
Now that we've talked about the payoffs and the trade-offs that we can associate with software quality assurance, an important question arises. Who does the work? It turns out that the software quality team actually combines a number of different constituencies. There is absolutely no question that software developers themselves are part of the software quality team. And in addition, we often have quality specialists, a software quality assurance group, who participates in a variety of different ways that we'll discuss a bit later in this component. It's also true that another constituency is indirectly involved. And of course, that's the customer. Because every emphasis on quality within the software engineering process keeps the customer's interests at heart. Let's examine the software quality assurance team in a bit more detail.
Isn't there some degree of friction that always exists between SQA and SE?
I think there should be a little bit of friction. Yeah, and healthy friction, there's nothing wrong with that. But sometimes I see outright warfare. Or if not outright warfare, subtle, almost nasty kind of backbiting, which I don't think is appropriate. There is a natural friction that builds up between software engineering and QA folks. If a team atmosphere is created, that friction can be friendly and helpful. But if the groups are set off against one another as conflicting organizations, then I think you have a counterproductive situation. The problem is that human beings are territorial. Okay? Given that, because software quality assurance people report up a different stream. Usually they report up through operations or up through manufacturing. I mean, it varies with the company. Software engineers report up through engineering. They view their territorial imperative as being different. You know, they have allegiance to different folks. Now, you can argue with some degree of credibility that that's the way it should be because you don't want pressures brought to bear. But the fact that they're separate also creates the friction.
Dr. Pressman, what is the best way to establish an effective working relationship between the SE and the SQA organizations?
If an SQA organization becomes perceived as a quality police, ipso facto, everybody else is a potential criminal, a quality criminal, then we have problems. Okay? So it is very important for management to establish an atmosphere in which truly a quality team is derived. If you look at the slide, what do you see? You see a representation that says that the software engineering group and the software quality assurance group work together to achieve high quality. The implication of this is, one, that both have common goals, two, that there is some reasonable allocation of responsibility, and three, that there is mutual trust that both will be working in the interest of the other.
What is the role of the customer in SQA?
Interestingly, the customer comes into the picture in a couple of different places. First, some obvious places. The customer will be involved in certain types of reviews. The customer will not be involved in all reviews, nor, by the way, parenthetically, nor should the customer be involved in all types of reviews. But the customer will be involved here. These are front-end customer contacts and front-end integration with quality assurance. The customer will certainly be involved at the back end. Okay? Formal qualification test, beta test, whatever you want to call it. The bottom line is the customer will participate in what we generically call high-order testing to ensure that requirements for the software have been met. So the customer gets involved there too, front end, back end. Now, where else? The customer invariably has some involvement in standards and procedures. In fact, your customers specifically may dictate a standard or procedure as part of contract. You must do it this way. Okay? The customer has less involvement in measurement, probably none.
What is the relationship between the SQA group and the customer?
QA, historically, going back to its origins in the early 1900s, QA is viewed as the customer rep in-house. It is the job of QA, actually, if you want to talk about philosophy, quality philosophy, it's the job of QA to protect the customer's interests in-house.
The overall goal of the software quality team is to achieve high-quality software. To do this, we can accomplish a number of sub-goals.
The QA organization's contribution to quality has more to do with monitoring and control than it does to do with construction. The role of construction is held by the software engineering organization. But the QA group monitors both the process and the product. Now today, there are some disagreements about this. As the SEI has pushed a software engineering process group or process organization, some people are beginning to believe that the monitoring of the process per se should fall under a process assessment purview. That's reasonable, but historically it has been the QA function to look at both of those areas. Each organization has to make those decisions on its own. Right? If, in fact, a process group looks at the process, it is performing a QA function. Okay? We can call it anything we'd like, but it is a QA function. The goal of the QA group is to ensure compliance with local standards for software engineering. And more importantly than local standards, we could broaden that to say global standards for software engineering. And the goal of the QA group is to ensure that any product defect Process variance or standards non-compliance is noted and fixed. Reading behind the words, we come back to my comment of a few moments ago. When you look at this, what that really says, what those 3 bullets really say, are very simply that the goal of the QA organization is to serve the customer's interests by performing those 3 things.
How do we achieve the software quality assurance goals that we've just gotten done discussing? At least part of the answer resides in an understanding of the roles that individuals play throughout the software engineering process. We've already discussed this in ESE Module 7-1, and if you haven't taken a look at that module, you might consider doing so at this time. But there's more than just the overall roles of players in the software engineering process. There are also some specific responsibilities that have to be accommodated and accomplished. Let's take a look at these responsibilities right now.
That QA needs to do, or should do, at least in my opinion, is to review the project plan to ensure that the project has defined a series of effective quality filters throughout their definition of the process. Are reviews scheduled? What kinds of reviews are scheduled? Is test planning scheduled? Is there a mechanism for controlling change? How is it spec'd in the plan? A primary danger from a QA person's point of view when they look at a project plan is to say, well, this is really of no interest to me. This is just talking about technical tasks, and I can walk away from it. Wrong.
In addition to reviewing the software project plan, the SQA function has a number of additional responsibilities. SQA participates in selected formal technical reviews to ensure that proper record keeping is maintained and that follow-up occurs at the appropriate time. SQA reviews all documentation for adherence to standard to ensure that the documentation and the software represent the same information. SQA reviews all test plans for completeness and consistency. This is a critically important activity that will result in testing that is more thorough and more accurate. The SQA function periodically audits the software configuration management function to ensure that changes are being properly addressed throughout the software engineering process. Finally, it's the responsibility of the software quality assurance function to report nonconformance of any of the software quality dictates to management. The reason for this is simple. If there are failings in the software engineering process, these must be corrected, and management must take the initiative to do this. Now, what do these responsibilities accomplish? Well, in reality, they accomplish many things. The SQA function ensures that a software engineering process exists and that it exhibits a reasonably high level of maturity. SQA ensures that standards and procedures are used and that reviews and audits are conducted, that effective documentation is produced, and that it is produced during, not after, the software engineering work itself. Software quality assurance ensures that change control mechanisms are in place and that testing has been planned, not simply ad hoc. SQA provides a set of exit conditions for each software engineering task. And it's these exit conditions that allow project managers to assess progress throughout the software engineering activity. Finally, SQA shows deviation from standard, exposes these deviations, and leads to recommendations that enable managers to correct any deviation that does occur. All of these things are a direct result of an effective software quality assurance function.
When we think about the role of QA, what we really think about is this. The process has a flow to it. Now, earlier on, we talked about spiral flows, evolutionary models, prototypical models, linear sequential models. But regardless of the paradigm that's applied for software engineering, there is a flow that occurs. We move from task to task as the flow proceeds. QA provides us with guidelines for establishing the exit conditions to leave one task and begin the next. In theory, we really shouldn't proceed from one task to the next until we've met the exit condition. Now, what's the exit condition? Well, it may be completion of a formal technical review. All right? And by completion, I mean that the review comes to a successful conclusion, and I'll talk about that later. Once we achieve that successful conclusion, we've reached an exit condition, and we can proceed. Maybe, instead of that, it's that we reviewed a particular change and approved it. That's a CM activity. That might be an exit condition to move from one task to the next. But the bottom line is, if you think of it that way, almost in software jargon, you can understand what the role of QA is as the process proceeds.
Dr. Pressman, should SQA participate in all formal technical reviews?
QA has limited resources. It is, I believe, personally, unrealistic to expect that QA would participate in all of them. In fact, it might almost be counterproductive. The philosophy that has to be fostered is that the software engineering team is also performing a QA function. It doesn't always need a QA individual standing there to hold their hand. If that's the kind of image that's fostered, you've lost. QA should participate in selected reviews for auditing, when a review is particularly critical, just to stay up on certain things. But the QA team, broader, the QA group, the software engineering group, takes responsibility for reviews. And the vast majority of formal technical reviews are performed by software engineers.
Dr. Pressman, when you say that SQA should ensure that effective documentation is produced, what do you mean?
It ensures that documentation is produced during, not after, the technical activity. That is very important. There is in our business a tendency to backfill. Okay? We do the work, then we document the work. That results in two things. One, ineffective documentation. Two, frustration and low levels of productivity. Three, less quality in the end result. The trend in software engineering today is to say that the activities that are performed during analysis and design, code and test, are activities that, as a consequence of their application, generate the information you need for documents. With the use of case tools, computer-aided software engineering tools, we should be able to assemble the documents almost in real time as we do our work. So we don't go back and document after the fact.
Can the SQA put quality into a product?
SQA is not the group or the organization that puts quality into a product. Okay? Simply. It does not. Okay? The onus is on the software engineer to put quality into the product. If the software engineer blows it, okay, if they do a miserable job of analysis and an even more miserable job of design and kludge a system together with chewing gum and baling wire, all the QA in the world isn't really going to help.
As we just noted, software quality assurance can't put quality into a product. If it's not there via the efforts of software engineers, software QA can't put it there. It's something to think about as we begin to establish a software quality function within an organization. It's also true that the existence of a software quality assurance function is no guarantee that quality will exist overall. Many things have to happen to achieve high-quality software. And it's also true that if management doesn't act on the recommendations of software quality assurance, the function overall will likely be ineffective. Finally, unless software quality assurance and development staff work together without hostility, little benefit will be derived from the SQA function. All of these things represent a dose of reality, and all of them should be remembered as you work toward establishing an effective SQA approach for your organization. But there's more, and let's examine that in the classroom.
Staffing the QA function can be a problem. In some organizations, it's difficult to find folks who want to perform this activity because it's an extremely difficult activity. You need to be both knowledgeable and experienced. Interaction can be a problem. Depending on the level of sophistication and knowledge of QA folks, there may be some difficulty literally in communicating with software people in an effective way. That's actually a management problem because there's never a problem in communicating unless people want to make a problem in communicating. Okay? Management is a problem. Very often, as we've just seen in this little story, management is not signed up to this. I mean, they may say the words, the mouth works, and the noises come out, but they're not really intellectually signed up to it. Standards are a problem, not in your organization, but many organizations today still have no standards when they're working. I got to tell you this. Okay? It would amaze you.
And finally, planning is a problem. Like most activities within the software engineering process, a systematic approach and plan works far better than an ad hoc approach. And software quality assurance is no exception. Planning is pivotal to conducting effective quality assurance. And because of this, many organizations develop a quality plan that focuses at both the project and the organizational levels. It is important to plan SQA, and every organization should do this to a greater or lesser degree. But is it important to create a separate software quality assurance plan? The only reasonable answer is, it depends. If your organization builds major systems or critical products, then a separate SQA plan is advisable. On the other hand, if your projects are somewhat more casual, you may be able to get away without creating a separate SQA plan and fold SQA functions within your project plan. But no less, it is important to define a systematic approach. If you intend to be formal about SQA planning, I'd advise that you take a look at the IEEE standard for software quality assurance plans. It's contained in this software engineering standards document, large and foreboding, but actually the SQA plan is a reasonably concise definition that organizations should adopt. It turns out that if you apply SQA planning effectively, your software quality assurance responsibilities will be accomplished in a much more effective manner.
Okay? Fundamentally, what we want to do is establish the responsibilities, the tasks, the exit conditions that are necessary to move through the project, to move through project tasks, to produce project deliverables, to achieve project milestones. Now, some people view the QA plan as nothing more than an extension of the project plan. And I can live with that if that's the way folks want to do it. In fact, for small projects, that's completely acceptable. You merely address quality assurance issues within the context of the project plan.
Many different tasks can be associated with SQA, and these tasks are applied throughout the software engineering process. Watts Humphrey, in his book, Managing the Software Process, proposes a set of SQA tasks organized by process phase. We'd suggest that you refer to your ESE component workbook at this time to review these tasks. By studying Humphrey's recommendations, you'll get a better feel for the scope of the SQA activity.
If your organization is typical of most software developers, you currently don't have a proactive approach to SQA. And it's important to develop one if you're really serious about software quality. But how to proceed? Let's spend a few moments talking about how to launch a proactive SQA approach. The first thing that you need to do is to convince management that this is the right way to go. And that means collecting metrics and then developing a bottom line argument that will show just what the current cost of quality is. To do this, you'll need to collect information like the dollar cost for each error and defect, the number of defects per 1,000 lines of code or per function point. With this data known, you'll be able to demonstrate just what it costs when you encounter an error or a defect. And this is an important piece of information that will help managers to believe that SQA is appropriate and important for your organization. You'll also need to educate senior, middle, and line managers on the importance of SQA and convince practitioners that SQA won't get in their way as they're developing software. You'll need to adapt an effective set of software quality assurance standards and establish an SQA function within your organization. As part of project work, you'll need to create a quality plan, and you'll need to implement the plan for each important project and for the organization as a whole. And finally, you'll need to debrief regularly and tune your SQA approach in a way that will make it most effective for your organization.
There is a growing trend throughout industry, not so much software industry, but industry, to become more quantitative about the way we look at quality. In the manufacturing sector, the use of statistical quality assurance has become the norm. The people who pioneered this concept, without question, were the Japanese. The people who invented the concept were American. But in fact, the concept wasn't used when it was invented in the 1940s in North America. The Japanese, in rebuilding after World War II, decided that the ideas of Deming and his colleagues would have merit. And those ideas were based on statistical QA. Now, can these ideas be extrapolated to the software world? There are many people who believe they can.
Fortunately, we can extrapolate statistical QA methods with relatively few major changes. When we talk about statistical software quality assurance, we use many of the same approaches and same measures that we would apply if we were involved in statistical QA for manufacturing. We begin by collecting information on all errors and defects. This can be done through proper collection of software metrics as the software engineering process proceeds. We then need to find the causes of the errors and defects that we encounter so that we can do a statistical study a bit later on. We need to isolate the vital few causes of the errors and defects that we find. This will enable us to move to provide fixes for the process itself. And finally, we need to conduct a series of tasks that will allow us to effectively accommodate statistical SQA in a pragmatic environment that will enable us to also do other important SQA activities. The basic statistical SQA tasks involve categorizing errors, storing the information that we collect for subsequent analysis, and creating what is called a Pareto diagram. The Pareto diagram graphs causes of errors and defects in a way that will enable us to establish the vital few causes for later correction. Once we do these things, we've established an important mechanism for software process improvement.
Dr. Pressman, when you say that information about the causes of errors and defects is to be collected, what do you mean?
That implies a couple of things. One, that we try to categorize the error or the defect. Is this error due to poor customer communication? Is it due to a typo? Is it due to some failure in design? Is it due to an inadequately specified interface? Is it due to a lack of thoroughness in testing, or some combination of those things? That's work. That's work. That requires a debriefing on each error that's uncovered. Why did it happen? But if we categorize the error, attribute it to some specific place in the process, try to develop some indication for the effort required to correct it, we can then move into the statistical area.
The use of phrases like statistical software quality assurance and vital few may be causing you a bit of concern, but not to worry. The level of mathematics here is relatively low, and determining the vital few is a very important activity if you intend to improve your software process. In fact, this concept of vital few leads us to a consideration of the proverbial 80-20 rule.
20% of the causes account for 80% of the effort and energy and defects that we uncover in software. Well, what does that say? It says that if we could isolate and correct the right 20%, we'd save ourselves some serious money. And if we continue to do that iteratively, continually re-isolating the 20%, we would truly improve our process and the quality of our product dramatically.
Dr. Pressman, what is a Pareto diagram?
The Pareto diagram simply represents classes of errors and their relative frequency for a project, for multiple projects, for some period of time across a software engineering organization. We can often represent the Pareto diagram as a histogram, very simply saying that what we're looking for are the highest frequency causes of errors and defects, the vital few. We look only to those with high frequencies, discounting the rest. Okay? If a problem occurs due to a cause once in a great while, we don't worry about it, at least not now. We spend our attention looking up here. Once we've collected enough data so that we can build this picture, we're ready to begin to say that these are the areas in process where I want to focus my attention on efforts to improve.
Let's assume that we determine that nonconformance to spec is a vital few causes. What's next?
I can develop requirements tracing tools. I can build a requirements database. I can build traceability techniques so that I can be sure that at each step along the way, I do have traceability back to specification. I can encourage better review and focus my review attention more on conformance to be sure that everything that I'm doing does in fact conform back to specification. I can look at the specification itself to try to be certain that it's clear and bounded and concise and unambiguous so that, in fact, conformance will be easier to demonstrate. My point is that once I know that this is a vital few problem, I can focus process energy on it to make it better.
Is it the same to record the point in time where the error was injected into the process rather than the cause?
Well, you might want to really record both. That's an interesting point when you say we record points of injection. That kind of gives you a chronological place where the error got in. But that might be different than the cause of the error, if you understand what I'm saying. In other words, let's assume that the error was injected during requirements time, okay, a very common place where errors are injected. What was the cause of the error? A lack of communication between customer and developer, a poor assumption made by an analyst, a lack of explicitness by the customer, etc. So I would argue the point of injection and the cause are both interesting pieces of data, but I would further argue they are probably different pieces of data.
In this module, we've talked about software quality assurance. We've discussed basic SQA activities and the payoffs and trade-offs that are associated with them. We've spent some time talking about the QA team and about the planning techniques that are required to get the job done. We've also spent a bit of time talking about statistical SQA approaches. A lot of information, no doubt. And I'd advise that you spend some time referring to your textbook and to your ESE workbook to solidify these concepts. In summary, suffice it to say that SQA is a critical project control activity. It leads to high-quality computer software, but only when high-quality software engineering is applied.
This concludes the video portion of this ESE module. Please refer to your ESE component workbook for the module post-test and recommendations for further readings and exercises. If you're unsure of any topic presented in this module, return to the videotape for another look. After you've completed reading and exercises in the workbook, you'll be ready to proceed to the next ESE module or component.